Okay, I'm here with Gary Kubo, our R&D specialist. Can you spell your name for us, Gary?
Sure, it's Garykubo.
Nice. Okay, first question here. What is extrude honing?
Extrude hone is a process that uses abrasive flow media. It's hydraulically based. It's monitored and metered through computers, and its abilities to do machine work is infinite. You can do
Yeah.
so break.
Okay, I'm here with Gary Kubo, our R&D specialist here at Extrude Hone. Can you please spell your name for us?
Sure, it's Garykubo.
All right. Now, what is extrude honing?
Extrude honing is a hydraulically forced abrasive flow machining process.
Correct. All right. What is the putty made of, and how does it work to clean out an engine?
Okay, the putty is made out of a proprietary silicone polymer, and it contains specialized silicon carbide particles. And as the process of flowing goes through a part, it's a honing effect.
All right. What car parts can we use with this process?
Generally, the parts that were typically done are like cylinder heads and intake manifolds, but it's not just fixed to that. You can actually do specialty machining processes like when you rifle bore an axle, when you want to smoothen the surface before you shot peen it, you can be used for that. Plus, you can do gears. It's unlimited. As long as the media can flow through the part, it can be processed.
Interesting. All right, what are the benefits for the automotive extrude honing, like when it comes to airflow for an engine, and why is it important to maximize the airflow?
Well, the airflow will dictate the volumetric efficiency of the engine. How much air can go into the engine and come out is the amount of, whatever amount of fuel you're putting in, it can burn. So the more air you can put in, the more fuel you can burn. So the efficiency is all based on air. Engine is action air pump. So
nice. All right, on average, about how much can extrude hone increase the horsepower and or fuel efficiency?
Well, the results will vary depending on the part. If you're starting from scratch, say like a rough, unshaped, ported head, I mean, the results, improvements could be drastic. But if it's just enhancing an already shaped and designed port, it's the little intricate areas in the port that either a tooling or traditional machining cannot get to, or if you want to use fluid dynamics and that science, I mean, this is obviously the best way to go, because whatever's in the way, it'll remove, and whatever's not in the way, it's not going to remove. So there's no guesswork.
All right. About how much does automotive cost for extrude hone?
On general parts, for like turbine wheels and cylinder heads and intakes, the price range is usually between $250 to $1,300. But we're also open to do custom parts, like very intricate, either block passages or oil passages, or again gear sets or transmissions. All that can be done, but that's more time based. It's all customized, based on tooling. So obviously, the more tooling we have to build, the cost will go up. But generally, between $250 to $1,300. Oh. And for the $1,300, it's for a pair of cylinder heads. So if you have a V8, it'd be for both.
All right. Great.
Is there other?
Okay, Gary, you touched on some other automotive components that can benefit from this process. Can you touch on a few more?
Sure, like we mentioned about the axle shafts or tubes. A lot of times on motorsports, tubes are rifle drilled in the middle to cut out weight. Well, when you rifle drill it, it leaves machine marks like a swirl from a cutter. Sometimes you can polish it, other times they're so small, like on some tubes, that you can't get in there. This is where the extrude hone process is very important, vital, because you can actually, it could be 30 thousandths hole. You can shove media through it and precisely remove all the stress risers and leave a really nice smooth finish with the grain flow going the right way as well. So that's a benefit. Also, like on crankshafts, on the oil passages, if they're machined, sometimes, if you don't polish it, or if you can't get into it and deburr it, That could be a stress riser too. Typically, they don't crack in that direction where the oil holes are drilled, but again, you never know. It might be just the right angle where, you know, a sharp edge can cut it and you just cannot get a way to divert it. Other places I can see it being a benefit would be like gears. You know, if you can build the tooling and flow the media evenly, you can. A lot of turbine wheels and compressor wheels on turbos are done. We found it making a pretty significant difference on some of the applications. Some of the newer stuff is billet, and there's a lot of calorie marks from the machining tooling from the CNC machine. There are times that it does benefit removing that, and there are other times it doesn't. But when it does, it's I think it's a very economical way of uniformly removing a polished, deburring and polishing a wheel that there's no other way to do it.
Right.
So.
All right. Tell us about some of the other industries that Extrude Hone works with.
Sure. Extrude Hone was originally designed or created for aerospace needs. There was a lot of components that were made that were either too large or too small or too intricate or just a maze of tubes or passages that traditional machining just could not either polish or deburr, or if there might be a special specification on surface finish that you just couldn't do. So that's where Extrude Hone came in. Also in the medical field, on very small components, whether it's for your heart or for your knee joint or a joint replacement. I mean, there's such small components. A lot of them have to be deburred, and the surface finish has to be very specific. The components are so small that you can't do it with a traditional, electrical machine or what have you. So this process is great because once you build the tooling, again, you can control the media flow, pressure. Also, the abrasive media that you're using could be specified, so it's very accurate. And we'd figure, well, if we can do it in the medical field and also in the aerospace, why not implement this in the automotive? Because it doesn't get more stringent as far as requirements and than medical or aerospace. So you're getting the quality and the specifications and the requirements in that field into automotive, which is kind of rare,
Right.
So,
Well, right on. I think that's about it. Thank you.